Right. Today we are going to discuss about water hammer. If the water is flowing through the pipe, if there is no obstruction in between, that is having same velocity. That means velocity of the fluid in the pipe is equal to V. Automatically there is no valve, there is no any obstructions, the velocity of the flow will be constant. Right. Consider a long pipe. Consider a long pipe of length A, B, and this is length between these two, A to B is capital L. One of its end is connected to the tank and another end is provided one valve. The end connected to the tank having the water H, the water level H from the center line of the pipe. If there is no close of valve at the other end, the velocity of fluid in the pipe V is constant. That is maintaining same velocity if there is no close of valve at the outlet or at the other end. Right? Now the valve is suddenly closed. The momentum of the flowing water will be destroyed, and consequently a wave of high pressure will be set up. If the wave of high pressure will be transmitted along the pipe, velocity equal to velocity of sound wave, right, may create a noise called knocking. That sound wave created noise, that noise is known as knocking, right. Next point. Also, this wave of high pressure, effect of hammering action on the walls of the pipe, and hence it is also known as water hammer. Right. In this regarding water hammer, the pressure raised due to water hammer depends on first one, the velocity of the flow of water in the pipe, that is the velocity of flow of water in the pipe, and length of the pipe, velocity of flow in the pipe, and the time taken to close the valve, right. And another one, elastic property of the material of the pipe, the elastic properties of the material, that means material used for the pipe construction. The pressure raised due to water hammer depends on length between A to B or length of the pipe, velocity of the flowing liquid in the pipe, and the time taken to close the valve, and also elastic properties of the pipe material. Right. Another one, this is the following cases of water hammer in pipe will be considered. First case, if the valve is closed gradually, this is the first case. Another case, the valve of the pipe is closed suddenly and the pipe material is rigid. Third case, if the valve of the pipe is closed suddenly and pipe material is elastic. Three conditions we are going to take into account. Right. Now we are going to discuss about one by one. Right. Gradually closer valve. Gradually closer valve. Right. If valve is closed gradually, if the water is stored on the tank, a pipe is connected, one of the pipe end is connected to the tank and another end is provided one valve. If the valve is closed slowly or gradually, what is the pressure wave developed in the pipe? What is the increased pressure in the pipe? That we are going to estimate here. Now consider a long pipe of length L, that is from A to B, and one of its end is connected to the tank. One of its end is connected to the tank, and the water level in the tank is H, that is from the center line of the pipe, and another end is provided valve. Okay, right. Now let A is the cross sectional area of the pipe, L length of the pipe, this is the length between A to B, and V is the velocity of the flowing liquid in the pipe, and P is the pressure, and P is the intensity of pressure wave produced. Small p is the intensity of pressure wave produced. Right? Now, mass of water in the pipe. Okay, these are the terms. One is length of the pipe, intensity of pressure wave produced, velocity of the flowing fluid, cross-sectional area of the pipe. Now, what is the mass of the flowing fluid in the pipe? One standard formula I have already explained. Mass equal to mass density into volume. Right? In this case, mass of the flowing fluid is equal to mass density into volume. Volume means area. What is the area? First, this is the cross-sectional area of the pipe is capital A, into length. This is the volume. Mass density into volume. Volume is nothing but area into length. This is the mass of the flowing fluid in the pipe. Right? Right. This is the mass of the flowing fluid in the pipe, that is equal to rho into A into L. Right. Now, the valve is closed gradually in a time t seconds. If the valve is closed gradually in a time t seconds, and hence the water is brought from initial velocity v to zero velocity in time t seconds. The velocity of flow in the pipe v, initial velocity, because of the closure of valve here, that velocity reaches to zero velocity at a time of t seconds. Okay. Now, therefore, retardation of water. Right, retardation of water is equal to change in velocity divided by time. What is the change in velocity? Retardation of water. Initial velocity is before close the valve, the velocity of flow in the pipe is v, initial velocity v. After close the valve at a time t seconds, the velocity in the pipe is 0. That is the initial velocity minus final velocity, change in velocity, divided by time. The time taken to close the valve is capital T. Okay. This is equal to V by T. This is the retardation of water. Okay. Retardation of water is equal to change of velocity divided by time. Change of velocity V minus 0. Initial velocity minus final velocity divided by T is equal to V by T. Velocity of the flowing fluid divided by time taken to close the valve. Now, retarding force. Force equal to, already I have given formula, force equal to mass into acceleration or mass into retardation here. Right, what is the force? Force equal to, what is the mass? Mass already determined. Mass of the flowing fluid equal to density into volume. That is, density is denoted by rho into A, area into L, density into volume. This is the mass. Mass into retardation. Retardation is equal to, just now we have derived V by T. This is the retarding force. Retarding force equal to rho into A into L into V by T. Right. Small p is the pressure wave produced by closure of the valve. The force due to pressure wave equal to, what is the force? Force due to pressure wave is equal to, already force equal to pressure intensity into force equal to stress into area, force equal to pressure into area, or intensity of pressure into area. Intensity of pressure produced here is small p, that is equal to small p into what is the area of the pipeline. This is the pressure intensity produced because of the close of the valve, pressure intensity wave produced due to closure of the valve, right? This is very clear. Intensity of pressure into area of the pipe. Equating the two forces, one is retarding force and another one is the pressure force. Right, what is the retarding force? Now equating the retarding force equal to pressure force. Retarding force equal to that is equal to rho into AL into V by T. Pressure force equal to small p into A. A gets cancelled. Therefore, rho L V equal to T. Therefore, force, pressure force, pressure, this small p is the pressure intensity, equal to rho L V divided by T. This is the equation. Pressure wave P is equal to rho L V by T. Right? Now this is the pressure. Pressure head is equal to, what is the formula pressure head? Pressure we have here, that is equal to rho L V by T. Pressure head is equal to P by W. This is the pressure. Pressure head is equal to P by W or P divided by rho G. Here P is nothing but rho L V divided by T divided by rho G. This is equal to rho L V divided by T into 1 by rho G. Rho gets cancelled. This is equal to L V divided by T G. This is the pressure head. Pressure head is equal to L is the length of the pipe, V is the velocity of the flow, T is the time taken to close the valve, and G is acceleration due to gravity. This is the pressure head. This is the pressure. Right, here also this is the pressure head, this is the pressure. Now, so here based on the relation 2L by C, we are going to clarify the valve is gradually closed or the valve is suddenly closed. Suppose here, if time taken to close the valve is more than 2L by C, time taken to close the valve is more than 2L by C, it indicates that the valve is closed gradually, where L is the length of the pipe, that is between A to B, and C is the velocity of pressure wave. C is the velocity of pressure wave. Another case, if T is less than 2L by C, time taken to close the valve is less than 2L by C, then this case is known as valve is closed suddenly. Valve is closed suddenly means the time taken to close the valve is less than 2L by C. Here also L is the length of the pipe and C is the velocity of the pressure wave. Right, now one more point here. Already we have derived pressure P is equal to rho L V by T. This equation gives the relation between this equation gives the intensity of pressure due to water hammer and time required to close the valve This equation gives the relation between the intensity of pressure because of the close the valve and time required to close the valve. Here, based on this statement, based on this equation, what is the equation? Intensity of pressure P is equal to rho V L by T. Based on this equation, if T is equal to 0, P is equal to rho V L by 0, this is equal to infinity. right? Based on this equation, if time is equal to 0, the pressure intensity is infinity. But conducted some experiments, it is concluded that the pressure intensity is not infinity, the pressure intensity is finite. That means this equation is applicable only if the fluid is incompressible and pipe is rigid. Okay, right. So earlier we have derived the pressure intensity because of the close the valve. The pressure intensity P is equal to rho V L by T. Based on this relation, if the time T is equal to 0, automatically the pressure is infinity. But this is as per our derivation, as per equation. But strictly speaking, they have conducted some experiments. Based on the experiments, the pressure intensity not infinity, the pressure intensity is limited, is a limit. Therefore, this earlier formula we have derived that the valve is closed gradually, the pressure intensity P is equal to rho V L by T is applicable only if the fluid is incompressible and pipe is rigid. Right, now we are going to discuss about suddenly close of valve. So earlier derivation, that is gradually close of valve. Now this is the suddenly close of valve. Right, for sudden close of valve, high pressure wave will be developed. Sudden close of valve, high pressure wave will be developed, and the liquid gets compressed to some extent, and also pipe material gets stretched, here because of the suddenly close of valve. First point is high pressure wave will be developed. Because of the high pressure wave, liquid gets compressed to some extent, and also pipe material gets stretched. These are the problems if the valve is closed suddenly. Here also, for sudden close of valve, the following two cases will be considered. For case 1, case 2, in case of sudden close of valve and material is rigid, pipe material is rigid, that is the case 1. Another case, sudden close of valve and the pipe material is elastic. Now we are going to discuss one by one. Sudden close of valve and pipe is rigid. Here also we are going to take one long pipe of length L, and one of its end is connected to the tank. The tank is having liquid, that water in the tank is H above the center line of the pipe, and another end is provided one valve. Okay, and also the valve is closed suddenly. Right, now A is the cross sectional area of the pipe. L is length of the pipe. And V is the velocity of the flow through the pipe. P is intensity of pressure wave produced, and K equal to bulk modulus of water. This is the additional term introduced here as compared with the if the valve is closed gradually. If the valve is closed suddenly, there is a one more term, that is K is equal to bulk modulus of water. And another one, if the valve is closed suddenly, the kinetic energy of the flowing fluid is converted into strain energy of water, and also effects of friction is neglected. In case of suddenly close of valve, the pipe wall is assumed perfectly rigid. Okay, if the pipe wall is assumed that rigid, here as per statement pipe wall is rigid, that is possible when the effect of friction is neglected. Okay, when the effect of friction is neglected, the pipe wall is perfectly rigid. Right, now here the kinetic energy of the flowing fluid, that must be equal to that converted into the strain energy stored. Now what is the kinetic energy of the flowing fluid? Kinetic energy of the flowing fluid is equal to half mass of flowing fluid into velocity square. Right, this is equal to half. What is the mass of flowing fluid? Already we have derived. Mass density into volume. Volume is nothing but area into L. Mass of flowing fluid rho into A into L into velocity square. This is equation number 1. Right? Next. Energy stored. Energy. Gain of energy. Gain of energy. Gain of energy equal to half P square divided by K into volume. This is the formula for the determination of gain of energy. Gain of energy is equal to half P square divided by K into volume. This is equal to half into P square divided by K into what is the volume? Volume is nothing but area into L. This is equation number 2. Now we are going to equating these two equations, equation number 1 and equation number 2. Equation 1 number represents that the kinetic energy. This is the gain of strain energy. Now these two equations are, now equating these two equations, half rho A V into V square. This is the kinetic energy equal to gain of strain energy, that is equal to half P square by K into AL. A gets cancelled. This is AL. That this is density of the fluid. Area into L is the volume. This is the mass. Right? Rho AL. A cancel. L cancel. 1 by 2. 1 by 2 cancel. Therefore, rho V square is equal to P square by K into P square by K. Now, P square is equal to rho V square into K, or P equal to square root of rho V square K. This is equal to V into square root of rho K. But we know one formula, K by rho equal to C. This is the velocity of pressure wave. Velocity of pressure wave C is equal to K by rho, root K by rho. This is one formula already I have given. C equal to velocity of pressure wave is equal to root K by rho. Therefore, this equation can be written as this is equal to V into square root of K rho into rho by rho, or this is equal to V square root of K by rho into rho square. Right? In place of this is equal to V, in place of root K by rho, we are going to take C into root rho square. This gets cancelled. This is equal to V C rho. This is pressure intensity P is equal to V C rho. V is the velocity of the fluid, C is the velocity of the pressure wave, rho is the mass density of the flowing fluid. Right? Pressure intensity in case of valve is closed suddenly, pressure intensity P equal to V C rho, mass density of the flowing fluid, velocity of the pressure wave, velocity of the flowing liquid. Right? This is about valve is closed, the corresponding pressure intensity. Right? Thank you, one and all.